Okay, so just came back from a 3-day trip from Port Macquarie, which is probably one of the best places maybe in the world for cold subduction metamorphism. So normally it's hot subduction metamorphism in the crust, but this one's in the ocean, so it's quite cold, and so you'll see rocks that you won't see anywhere else. So I bet you've never seen blueschist, and even serpentinite is difficult to get a handle of. So I'm just going to go through this worksheet now. I'm either going to refer to these. This is the pamphlet, and if it doesn't look like this, I've gone to either the source document or some other research, or the actual photos that I took. So first of all, I think just as an educational value, they've tried to make it simple, as if everything's been squished up um, from all of this, and then it sort of matches 1, 2, 3, 4, 5, which is not realistic. You can see from the real source document that you can have basalts all throughout this entire section. So is serpentinite. The blue schist is only found in this one little location, and then sediments and cherts are everywhere too. So it's worth going through the terms here. Um, and I'll just leave these ones here. The ones they don't mention is that for an accretionary wedge, which is what we have, it's a mess. And this one is truly a mess. And so just before I start, I think they try and simplify it. But if you go to the source documents, they call it a mélange, which means mix in French. And then they go and describe it as multiplied, deformed, polymetamorphosed, and then they say things like the rock has an intermediate composition between uh, amphicite and serpentinite. So it's just a mix. That it's just a complete and utter mess, which is what an accretionary complex is. So the other thing that integrates with it is the Watonga Formation, and that's a chert, slate, sandstone, metabasalt assemblage. So it's just a complete and utter mess because it's an accretionary wedge. And so that's actually what we're quite used to. So, first of all, I kind of skipped. I'll show you some pictures now of 2 and 3, because 2 and 3 are sediments and chert, and they're in. We're in Brisbane in the Nerranly Fernvale beds, and there's sediments and cherts everywhere. So even though I'll show you some pictures of that from the trip, it's really you can see that anywhere, especially in Brisbane. It's hard to get away from it. And so, what was special is finding dykes is difficult, and serpentinite and blueschist and eclogite is pretty much impossible. So, they're the ones I'll focus on, and how to find them in Port Macquarie. Now, the only other thing that is not great. Now, I used far more detailed maps than this, and even this, I went to the source maps that had them a little bit more detailed. And the only other thing I didn't like about this being a tourist map is let's go to these ones first. Um, these things here are from universities, and they're finely cut, thin sections. Um, and you can only do that with an expensive machine. Um, and then you need a polarized microscope sometimes for some of these. So there's no point, you're not going to see that, and you're going to see that one either. You're not going to see that in um, down on this one as well. You don't have a microscope. You don't have something that can cut things really thinly. Um, and hopefully, and so yeah, you're not going to see those things. So those things are written off. Um, the next thing is hopefully I've shown you uh, sediments and folded cherts. And so that's all that done as well. So I don't need to see that. That's not what we're interested in. We're getting to the good stuff, which only Port Macquarie has. The last thing is this thing is so precious. Unfortunately, people are cutting it, stealing it. I don't know how long we're going to still have this for. And if they go crazy over just a green with blue bits in it, anything that's going to have, I couldn't find this anywhere. Um, the eclogite that has the garnets in it. So this is meant to be eclogite too, and so I'll show you the picture of that. But if there is eclogite with garnets in it, if they're cutting these rocks out and walking off with them, anything that's like this would have been gone a long time ago and sold for hundreds of dollars for a small piece, a handful. So that's like having bits of gold lying around. That's not going to survive and that's gone. And I trekked up and down cliffs for 3 days, so I couldn't find it anywhere. So that's gone. And so these ones are the ones we're going to focus on. And so the pillow basalts, I can't find those in Brisbane. Like the pillow basalts and the dykes, they're present, but they're very hard to find. Now, if you look at these pictures here, you can see that the geologists are very good at finding them, but I find it's very hard to get them. So you can see I've found a few dykes around the place, and they're clearly dykes. And so what I'll just show you is some really good dykes. Now, this one here is on Shelley Beach, and this one I sort of considered as the best one because it's clearly a fault, and then it's clearly filled in with a different rock. And then what's really cool is you can see it's a fine grained matrix uh, on the outside, and on the inside it's more rough, and so it cooled much quicker on the outside than on the inside. And so that's probably the best dike you're going to see, um, even though there are other dikes around. But that one is by far the best and the best example of a dike I've ever seen. The next one is I wasn't very comfortable with is pillow basalts. Now, I think Flynn's this one I'll go to Flynn's Beach, even though we're meant to be on Shelley Beach. Well, these are the pillow basalts on Shelley Beach. And, because I'm not a volcanologist, I'm not super confident on them, but they are rounded and described like they say. And then if we go to Flynn's Beach, I feel like they were a little bit more obvious for some of them. So pillow basalts, um, kind of cool. Only forms underwater, so that's very difficult to find anywhere around where we live in Australia. Okay, so just cross off that other dikes approved, and the pillow basalts are done. And lastly, because we didn't get outside the Oregon, the continent, and this accretionary wedge, this subduction that goes all the way down from Brisbane to Port Macquarie. And so what you're going to get is often grey wacky and basalt are hard to differentiate. So if you can see phenocryst crystals inside the basalt, it's just, straight away it's basalt. And I even got the pink and blue phenocryst. So the feldspar is the pink, and I'm wondering whether the blue is the rare blue schist, because it's in the same area. It would make perfect sense. Um, so that's nice because I know it straight away it's basalt, because sometimes it's both dark, fine grained. It's hard to tell. So that's really quite useful too as a distinguishing characteristic. And so finally, we get on to the really good stuff. The reason why we're down there, and what's really hard to find is the serpentinite, the blue schist, and the eclogite. And so you can see the serpentinite around the place, but to get to the really good stuff, you have to go to Rocky Beach. Now they say look down from on Rocky Beach from the cliff top. You're not going to see it thing. You can't see any of the blue schists. You can barely make them out. That's the huge pieces, and the others are just not visible. I took pictures. I walked all along the top and took pictures to see whether you could see once I knew where they were, and you can barely make them out. I even asked a tourist to tell me if they think that's blue, and they go, nah. So it's just not really workable. Um, you really have to go down there. So you have to scale down cliffs. And the serpentinite is made of three serpentine minerals, and one of them is asbestos. So the white fibrous one. So it's not safe. Chemically for your health, it's not safe, and hazard wise, it's not safe to go down these mountains. So it's not. It's amazing, but again, it's just a little bit too dangerous, but I've done it for you. So you can watch this video and appreciate it, hopefully. All right. So the first day I went down to Rocky Beach, I did see the blue schist and only a few bits. And then it took me a while to work out where all the secret paths are off the track into the bush, these random paths, and where they lead and whether they're safe enough. And so eventually, the first thing I did find was the serpentinite, and it was just everywhere, and it was super waxy and greasy. So unlike the school samples, it was way better than the school samples because I could only find one that was slightly waxy, and these are really soft and waxy. So that's the lizardite. And then I could clearly see the fibrous ones. I didn't actually scratch these ones, probably because my knife is actually too hard. So I've got to see how easily it scratches because it almost scratches everything. Well, at least it tells me it's not quartz because potentially all of these rocks I've been mentioning can have quartz, especially these things that are metamorphosed several times. Um, and then the very last thing I was to find was the stronger antigerite. And that was definitely harder to scratch, but still scratchable. But it was less than 6.5 or whatever, so that makes sense. And so you could clearly see all three types of serpentine, but you had to really go to Rocky Beach to really see that well. And it is chemically dangerous because there are asbestos fibers in there. And so that occurs only in subduction. So for some reason, these serpentinite, which is just called serpentine sometimes, these blue schist, which is getting more pressure at cold temperatures, and then the eclogite, um, they're formed deep within the crust. For some reason, they're being upthrust, and we can actually see them on the surface. And the only place I know of in Australia is Port Macquarie, and even some world famous geological sites, top 100, don't have stuff as good as this. There are accretionary complexes that are nowhere near as good as Port Macquarie, and Port Macquarie is barely on the radar. There's a lot of research that's been done, but it's not the most famous for some reason. It's a hidden secret. And so the next rock, if we is sort of blue schist, and so I need these sort of interlock with each other. So if we just go to blue schist, so blue schist has this really metallic sheen to it, and it like a schist or a phyllite um, wood, and you can see the striations there, and it's this really magnificent blue. And going down, I eventually found all these bits and pieces, and each of those dots represents basically a big boulder of the stuff. And so that's blue schist, and you're pretty much good luck in finding that anywhere else. So it's a layered, shiny metallic substance. Now, it can be lawsonite blue schist or epidote blue schist. And you can see here, I can see these light purple crystals on there, almost clear. And so that looks to me as if it's the lawsonite, which makes sense because this one's a really deep one, which makes it even more rare. And just be aware that the blue schist also can be dangerous asbestos when the glaucophane is has a lot more iron in it. Now, what's even more special about the just finding the blue schist is even at the very most end, there's eclogite. Now, this is extremely rare and hard to find, and just before melting occurs. So that's why it's so difficult to get. And if you look at where the eclogite is, just look at the crazy formations all around, just in that little area. There's hyper metamorphism all over the place. It's just craziness. And that's where you get the eclogite. Now, we didn't get garnet encased eclogite. We've got blue schist encased eclogite that is probably, I don't know where you would ever see this. And it's been stolen, as you can see, it's been cut away. And you have to go down to see it. There's no way on earth you can ever make sense of that from a cliff, the top of the cliff. And so that one finally, that took till day 3, right? That's how much searching and hard work it took. And once you're there, you see all of these things. So you're not going to see these from the top of the cliff on Flynn's Beach, which is next to Rocky Beach. You have to go down. And these are called facholiths because it's kind of picked up the xenolith of this blue schist encased in this green material, which is the eclogite. It's also encased here in serpentinite. All right, and as the document said, sometimes it's serpentinite, sometimes it's eclogite, sometimes it's actinolite. There's all sorts of metamorphism, and then degrading from metamorphism as it upthrusts, and then transferring. So it's just a big mess of all different chemicals. But the geologists have the advantage of being able to scan use machines to work out the chemical compositions of them, which you're not going to have just looking at the rock or taking its characteristics. And you can see the facaliths that have been taken up particles and stretched out. And so that's interesting. That's the super subduction going on. And so we've got the serpentinite with the blue schist in it, and we've got the eclogite with the blue schist in it. But all of the good stuff here on the right hand side, you had to climb down the cliffs, and that's the really rare, brilliant stuff. The stuff on the left is just really good examples of Port Macquarie, but you can find them almost anywhere. The stuff on the right you can't find anywhere. And so that was an amazing place to go looking for rocks. And I have 100, maybe hundreds of other pictures and video, but I'm only just showing you a selection because I don't want it to go too long because I understand not everyone wants to hear me talk for 3 hours about Port Macquarie. And so I'll leave it there.